Today, we are going to talk about trees. So first, I want to formalize some definitions because some people get mixed up between trees, binary trees, and binary search trees. To put this simply, binary search trees are a subset of binary trees, and binary trees are a subset of trees. Whether it's a tree, binary tree, or a binary search tree, they all need to satisfy the basic characteristics of a tree. If the data structure satisfies these characteristics, then it is a tree. We will talk about each of them and visualize it on this tree example. First, let's see the basic tree characteristics. A tree needs to have a root. A root means that it's a node without a parent, like this one. Here's an example of connected nodes. That is not a tree. As you can see, there is no root node. This is actually a graph, which is a superset of trees. Next, all the nodes in a tree must have exactly one parent. As you can see, every one of them, except for the root, has a single parent. If there are any nodes connected like this, then it wouldn't be a tree. So nodes can have only one parent, but they can have multiple children, like we do here. That's pretty much what's needed to be considered as a tree. So basically, a tree needs to have a root, and a child node should have exactly one parent, but a parent can have multiple children. So just for fun, do you think this is a tree? It looks very much like a linked list. Technically, it is. You can think of it as a tree and all their nodes happen to have only one child. So it looks like a twig. That's the word I use for a tree that looks more like a stick. Okay, now for binary trees, a binary tree is just a tree, so it has the same constraint as a tree, but with one more constraint. The nodes can have at most two children. Usually, we call them the left child and the right child. So to make our tree into a binary tree, we cannot have nodes like this because we want to make sure each node only has two children or less. Finally, what is a binary search tree? Well, you guessed it. It's a binary tree, so it has all the properties we listed before, but it also has another property. The nodes are ordered from left to right, meaning given a node, all nodes in the left side, we call this the left subtree, must have a value that is smaller than the current node. And all the nodes from the right side, or the right subtree, have to be greater than the value of the current node. It is called binary search tree because having it sorted like this allows us to search for values a lot easier by performing a binary search. More on that in the future. So this is the summary of what we talked about so far. On top of the basic tree restrictions, remember that binary trees can have only up to two children. And on top of that, binary search trees need to be ordered. Now that you know the difference between trees, binary trees, and binary search trees, let's go over some terminology for trees. I've already previously used words like parent, children, root, and subtrees, so let's see some other ones. A leaf node is a node that has no children. So in this tree here, these would be the leaves. The definition of the height of a tree is the maximum number of nodes from the root to a leaf. So for our example, the height is 4 because the longest path from the root node to a leaf node is this one, which contains 4 nodes. That also means that if it's an empty tree, the height will be 0. Great. So you've learned about trees. You'll see that you'll be using the binary search tree a lot in this course because of its special ordering property. So in the next lesson, you'll learn how to construct a binary search tree and how to insert elements into it.